They want us to solve for x 1.1. So in most cases, this question has to do with vectorization and the likes. So with 1.1.1, we're being told that if we have bracket 3x minus 6, close bracket, and then x plus 2 is equal to 0. This question is 2 months. Now, I know someone might be tempted to open the bracket, and that is going a long route. Okay, so from our dot product, where we know that if we have two numbers being multiplied to be giving us a 0, it's either one of them must be a 0. So since these are the factors that we're looking at, we can say that 3x minus 6 is equal to 0, or x plus 2 is equal to 0. And then we can solve right away. So I'll move the 6 that side. 3x is equal to 6. And then I'll divide both sides by 3, which means x is going to be a 2. And in this case, if I transpose the 2 that side, x is going to give me a negative 2. So those are the two answers for 1.1.1. So ideally, if this is kind of challenging, yes, you can still open up and use the quadratic formula, but it's just going to take you a bit of time, but you still get the same answers. Then 1.1.2, we have 2x squared minus 6x plus 1. Now, whenever we have this condition, correct two decimal places, we definitely have to use the quadratic formula. Okay, so we say it's 2x squared minus 6x plus 1 is equal to 0. From our quadratic formula, we know that x must be negative b plus minus the square root of b squared minus 4ac divided by 2a. So from this standard form, okay, it's always important to represent your equation in standard form. Okay, so our a is going to be a 2, our b is going to be a negative 6, and then the c will be a 1. And then we just substitute into the formula. So it's going to be negative, but with a negative 6, plus minus square root. We have negative 6 squared minus 4. Our a is 2, and then our c is 1. I'm dividing this by 2 times a. So my a is a 2. Okay, so then we said we're just going to have to use one sign at a time. So I'll have my minus 6. I'll start with a plus in the middle here. And that is square root of 6 squared minus 4 times 2 times 1 over 2 times 2. I'm getting 2 comma. Okay, so x is 2 comma 82. And then what if I just go back and replace that with the minus? I'm ending up with 0.177. It's going to be 0.18. Okay, so those are the two answers that we expect. Then 1.1.3, we have x squared minus 90 is greater than x. So step number 1, we need to create a standard form. So we need to move this x to that side. Okay, so that it is x squared, and this x moves that side, it's going to be minus x. And then we have minus 90 is greater than 0. So still, this is a quadratic. Okay, so we say that for 1.1.3, we have x squared minus x minus 90 is greater than 0. Okay, then I can use my vector method, or I can use the quadratic. If I use the vector method, it means I'm looking at 10 and 9. So x and x, this can be 10, this can be 9. It's greater than 0. And put here minus and a plus. Since negative and positive will give me a negative, negative 10 plus 9 will give me a negative 1. Okay. Now, for as long as we have the inequality symbol of greater than, okay, we need to first of all know our critical values. So let me say that my critical values are going to be positive 10 and negative 9. Okay, then how do I represent that? So for as long as the sign is greater, then we're going to say that x must be less than the smaller value, which is negative 9, or x must be greater than the bigger value, which is a 10. That occurs only if the sign is greater. If the sign was less than, then you can represent it in the negative 9 is less x and then less 10. Only if the sign is less than. Okay. That is one way of representing the solutions. The other way is by simply drawing. Some people prefer drawing a parabola somewhere there. Okay. And with this parabola, since we know that the sign is greater, okay, we can just have a sketch, just a sketch of any sort. So these answers, these critical values will represent the roots. So probably that's a negative 9, and then this is your 10. Okay, since we're focusing on greater, then we can use arrows to say that our solutions in that direction and in that direction. Okay, so that is that. 1.4, 1.1.4. Being told that you have x minus 7 root x is equal to negative 12. So with such questions that have square roots involved, the deal is very simple. Just isolate this root sign. Okay, move anything that is bordering the root sign with either plus or a minus. So the only thing I see is this x. I can choose to move the x that side so that the root 7 and the 7 root x is on its own. I can do the other way around, move this that side and then move the root 7 that side. Whichever, it's going to be simpler. So that's going to be x plus 12 is equal to 7 square root of x. Okay, so that's going to be my first step for 1.1.4. Okay, so we're saying x plus 12 is equal to 7 square root of x. Step number 1. Then the next step is for you to eliminate this square root sign. Okay, and we can do that by squaring both sides. Okay, you square both sides, then we need to expand this. We can use the FOIL since it will be x plus 12 and then x plus 12. So that's going to give me x squared plus 2 times that is 24x. And then 12 squared is 144. Is equal to, now this square affects the 7. So that's going to give me 49. And then this square will affect the root sign and it will fall away. And then I'll just have x. Then I'll bring the 49 to the left. So it's going to be x squared plus 24x minus 49x plus 144 is equal to 0. I need to create a standard solution. Okay, so that's going to be x squared. This is going to be, is it minus 25? Let's confirm, yes, minus 25x plus 144 is equal to 0. Then I can use my quadratic formula or I can still use my factors. So the two numbers that I can multiply to give me 144, but when I add them, I get negative 25. Can it be 16 and what? 16 and 9? Isn't it? Yeah, perfect. That's going to be x and x. That is 16. This is 9. Minus, minus, since I'm having a plus now, the product. Then I can equate this to 0. Then I can solve this. So this is going to give me x minus 16 is equal to 0. Okay. Or x minus 9 is equal to 0. So this x will be 16, and then this x will be a 9. Now we do not stop at that. Okay, for as long as we have square root signs involved, we need to go back to the question and test to see which solution satisfies the given expression. Okay, so if I have my x minus 7 square root of x is equal to negative 12. So let me test x using 16. Okay, so if I put here 16, replace that with the 16. So that's going to be 16 minus 7. The square root of 16 is 4. Okay, so what is 16 minus 7 times 4? I'm getting negative 12. Okay, which corresponds with what I have on the right-hand side. So 16 is fine. Then let me test it again with 9. So this is going to be a 9. Minus 7 times the square root of 9 is 3. Okay, which also gives me negative 12. So which means both solutions are correct. Okay, so that is 1.1. Then 1.2, they want us to solve for x and y simultaneously. Now what happens that in this case, we need to look for what we call a linear equation between the two. Okay? So x times y cannot be linear. But 2x minus y is equal to 2 is a linear equation. So what I'm going to do, I'm going to first baptize that as equation 1, and then baptize this as equation number 2. Then I'll make y the subject, which means I'm going to move y to the left. I'll move y to the right, move 2 to the left. So that my y, or 2x minus 2, is equal to y. I'm going to call this equation, probably star, or equation 3. Then I need to substitute this equation star into equation number 2, where I see y. I'm going to replace it with all of that. Okay, so that's going to be x into, we said 2x minus 2. So 2x minus 2 is equal to 4. Equal to 4. So we need to see all those other steps also of the baptizing, the naming them, and making this the subject before you can do the substitution. When I open this up, I'm going to have 2x squared minus 2x is equal to 4. I can transpose the 4 that side. So that I have 2x squared minus 2x minus 4 is equal to 0. Then what I can see is there is a 2. I can divide through by 2. So over 2, over 2, over 2. On that side over 2. So that I have x squared minus x minus 2 is equal to 0. So it's a quadratic in its standard form. I can use vectors, or I can use the quadratic formula. So x and x, the numbers I multiply to give me 2 will be 2 and 1. Since my sum is negative, I'm going to have a negative and a plus. Okay, so x plus 1 is a 0, or x minus 2 is a 0. So which means x here is going to be negative 1, then x here is going to be the 2. Then I'll get these solutions of mine and substitute them into that equation star, where we said it is 2x minus 2. Okay, 2x minus 2 is y. So which means my y is going to be 2 times negative 1. It's negative 2 minus 2. It's going to give me negative 4. And then this side, this 2 times 2 is a 4 minus 2, which is a 2. So this will be our solution, negative 1 and negative 4, and then 2 and 2. That is question number 2. So 1.2. Then let's look at 1.3. 1.3. Can we show that 2 times 5 to the n minus 5 to the n plus 1 plus 5 to the n plus 2 is even for all positive integers of n? Okay, so in this case, what we need to do, I see there is something that is common. There is 5 to the n, 5 to the n everywhere. So I need us to break this down and factorize that 5 to the n out. Okay, so this is going to be 1 from 3. So we say 2 times 5 to the n minus 5 to the n plus 1, okay, plus 5 to the n plus 2. Now we know that from our laws of exponents, okay, we have a to the m times a to the n to be the same as a m plus n. For as long as the bases are the same, we add up the exponents. So we have this kind of scenario, and I want us to move from this format back to the original. Okay. So the first one, I can leave it since there's nothing special. But now with the second term and the third term, I have to split up. So that's going to be like 5 to the n times a normal 5. And then plus, this is going to be 5 to the n times 5 squared. Because when I apply the laws of exponents, I'll go back to that. Then I can see that 5 to the n is common. I'll factorize that out. I'll be left with a 2 minus. I'll have a 5 there plus 5 squared is going to give me 25. Okay, then that is 5 to the n. This is going to be just a 20 plus 2. Then I'll have 22, something like this. Then it is from this statement that I can draw the conclusion. Okay, they want us to show that this whole expression will be even for all positive integers of n. Okay, so we know that even numbers, what are even numbers? 22 is an even number. Yeah. So we're going to say that any integer, okay, any number or any integer, start the spelling of integer. Any integer that is multiplied by an even number will be even. Okay, so what does this mean? Guys, if we replace n with, let's say, remember they told us for all positive integers, okay? Let's replace n with the 1. It will be 5 times 1, or it will be 5 alone, okay? Times 2. So this is an integer that is odd times even, okay? We end up with an even number. If we replace n with a 2, it's going to be 25 times 22, which is going to give us an even number, and so on and so forth. And that's why we have this kind of conclusion. Okay, that's what they wanted to do. Then 1.4, determine the values of x and y if 3 to the y plus 1 over 32 is equal to that. Now we still have some exponents here. So what we need to do, we need to break down the 96, we need to break down this 32. I hope that will make sense. Okay. Let me just check it. 3 to the y plus 1 over 32 is equal to the square root of 96 to the x. Okay, so I know 3 to the y plus 1 is fine. 32 can be written as 2 to the exponent of 5. You can use your calculator to do that. Huh? press 32 equals and then shift, and then the factorization button. Okay, that button with the dot comma something. After pressing shift, you get that. Then I'm gonna do the same thing with 96. How can I write 96? With its factors, it's gonna be 2 to the 5 times 3. But remember, everything is to the x. Okay. Then I need to get rid of the square root. I don't know if I should square both sides, so it makes sense. I can just write it. We know that anything under square root is the same as exponent a half. I think I can use that. So 3y plus 1 over 2 to the exponent of 5 is equal to 2 to the 5 times 3. But everything is going to now be x over 2. Since I'm using square root as exponent a half. Then I'm going to multiply this into everything. Let's see. We have 3y plus 1 over 2 to the 5. And multiplying to that is going to be 2. That's going to be 5x over 2. And then 3 to the exponent of x over 2. Okay, I think I'm ready to go now, okay? Then from there, I can compare the left-hand side together with the right-hand side. So I'll compare the twos on their own and then the threes on their own, okay? So when I start with the threes, I have 3 to the y plus 1 being equal to 3 to the x over 2. So the bases are the same, I'll consider the exponents. So from there, I can see that y plus 1 is equal to x over 2. I can move to on that side so that y is the same as x over 2 minus 1. I can leave it at that point. Then I get to the 2's. We can see that this 2 is a denominator. I can shift it to the top so that it can have a negative exponent. Is equal to 2. This is 5 over 2x. I'll drop the bases so that I have negative 5 is equal to 5 over 2x. And then I can divide both sides by 5 over 2. Okay, and I divide that by 5 over 2, I'm getting a 2. So which means my x is a 2. Let's see. So say it over 5 over 2, then divide by 5 over 2. So our x is a 2. Now get this x and replace it somewhere there. So that my y is 2 over 2 minus 1. And then I'm getting y as a 0. Does that make sense though? Y to be a 0. No, man, sorry guys, it's not a twist, negative 2 here. Since we are dividing with negative 5, negative 2. So that can't be 0. So when I replace it there, it's going to be negative 2 over 2, which means it's going to be negative 1 minus 1, which is also going to be negative 2. And y 0. Okay, guys, so that is how we would have gone about with 1.4. Then question number 2, which is the number pattern, sequences and series, and telling us that the first sum of the geometric is the keyword here is 14. So our A is 14. And the sixth term, okay, T6 is 448. Calculate the value of the constant ratio. It's 2 marks. It's 2 marks. So this one, we know that the general term of the geometric is Tn being given as AR n minus 1. Then if we're talking about, let's say T6 is going to be AR 6 minus 1, which is going to be 5. And then I'll replace, so it's 448 is equal to our first term, which is a 14, r to the exponent of 5. Okay, then we can divide both sides by 14. What is 448 divided by 14? 448 divided by 14, I'm getting a 32. The 32 is equal to r to the 5, and then I'll find the fifth root. Okay, the fifth root of 32. So we can press the shift and then that cube root button, and then we move backwards and change that 3 to a 5. Okay, then we enter 32, and then our r is a 2. Okay, so our common ratio is a 2. Then 2.1.2, they want us to determine the number of consecutive terms that must be added to the first 6 terms in order to obtain a sum of 114,674. How many terms must be added to the first 6? So which means we have six terms that have already been added. We must add something. And we need to find how many terms are here. All right, so I think we can find the number of terms that we used all together 114,674. The answer we get, we can subtract it with 6 so that we get how many terms will be added. I don't know, that's my reasoning. Because if I get the number of 6 terms or the sum of 6 terms, it's not going to make sense for me. Okay. So how do we get the sum of a geometric? This is 2.2. We know that sum of the geometric is A. Is it AR? It's A. Let's use Rn minus 1 over R minus 1. So we've been given the sum as 114,674. So 114,674. We know that our first term is 14. Our common ratio was a 2 to the n minus 1. And it's going to be just 2 minus 1. Then 2 minus 1 is not a big deal. My problem is now for me to eliminate this 14. I'll divide both sides by 14. 674 over 14. It's going to leave me with 2 to the n minus 1. Remember, we said 2 minus 1 is 1, so no effect at all. 114,674 divided by 14, I'm getting 8191. Yes, is equal to 2 to the exponent of n minus 1. Then I can move the one that side, which is going to be a plus. So 8192 is equal to 2 to the exponent of n. Then 8192, I use my factorization. It's giving me 2 to the 13 is equal to the exponent of n. So the bases are the same, which means n is having, we are looking at 13 terms. Okay, but the question is asking us, okay, determine the number of consecutive terms that must be added to the first 6. So we're gonna say 13 minus 6, which is 7 terms that must be added. That is my understanding of this question. Okay. So I'll get my answer as 7 terms. Then 2.1.3, this is 2.1.2. 2.1.2, okay, 2.1.3. They're telling us that if the first term of another series is 448, okay, and the 6th term is 14. So it's like we're swapping them around, okay? If the first term is 448, and then the sixth term is 14. They want us to calculate the sum to infinity. So if they have been swapped around, which means the new sequence becomes a converging one. Okay, so let me take this out. Okay, so we know that T6 is 14. And then if I use that Tn, we're saying AR to the 5. That is if I'm looking for the sixth term. So that's going to be 14 is equal to 448 R to the 5. If I do the same thing, I'm going to have 1 over 32. And then the fifth root is going to give me a half as my common ratio. Okay, so this I need to know. Then I know that sum to infinity will be given as this one, no, it's 2.1.3. It's given as A over 1 minus R. So our first term, we said it's 448 over 1 minus the common ratio, which is a half. Punch that into the calculator. I'm getting 896. So that's what we get. So step number 1, you need to find the common ratio. Then use the common ratio to get the sum to infinity. 2.2, if the sigma from p is equal to 0 up to k over 30p plus a 6 is given as 21 over 6. I want us to determine the last term. So when they talk about sigma, that is we're adding up. But we don't know whether this is a linear or geometric, or we can find that out. Okay. So step number 1, try to replace the values of p into the expressions. Okay, so when I use p as a 0, my first term is going to be 1 over 6. And then if I use p as a 1, that's going to give me 1 over 2. And then if I use p as a 2, okay, that's going to give me 5 over 6. Okay, so from this, what do I notice? Is this an arithmetic? Or, but just by looking at the way it is expressed, it's more of an arithmetic. But let's confirm. Let's subtract. What is D1? So I have minus 1 over 6. I'm getting 1 over 3 as my difference. If I try to get that, 5 over 6, okay, minus a half, I'm also getting 1 over 3. So which means my common difference is 1 over 3. My first term is 1 over 6. Now, since I know that it is an arithmetic, then I need to use the formula for the sum of an arithmetic. Okay, which is Sn is equal to n over 2 into 2a plus n minus 1 into d. Okay, so we've been given the Sn as 21 over 6. 21 over 6. We can change this to an improper fraction. So that is going to be 121 over 6. So 6 times 20 is 120 times plus 1, 121 over 6. Do we know the n? We don't know the n. That's what we're looking for. We know a, we know a d. Then we're good to go. So it's going to be 121 over 6 is equal to n over 2, open brackets 2. We said our first term was 1 over 6 plus n minus 1, our common difference is 1 over 3. Okay, so what I need to do, I don't know if I should open the bracket. So let me do the quick one. Let me just multiply this by 2, and then this side by 2. So that this 2 cancels that 2. And then that's going to be 121 over 3. 121 over 3. Now I'll maintain it as that. When I open this is going to be n over 3, because 2 times 1 over 6 will give me 1 over 3. And then times n, I'm getting that. Plus, so this and that is going to be n over 3. Okay, but I'm multiplying with n again. So that's going to be n squared over 3 minus 1 over 3 n. Some people are confused now. Okay, let's do this step by step. Okay, I'll leave the n outside. That's going to be 1 over 3 plus n over 3 minus 1 over 3. Are we there? Someone can cancel this, and then we're going to have 121 over 3 is equal to n squared over 3. We have the same denominators, so times 3, so that the 3's cancel out. So then we have n squared is equal to 121. Then we find the square root on either sides. So square root is always positive, negative. But since we're talking about positions, which means our answer is going to be 11. Okay. So in this case, we're going to say that since n is 11, which means we have 11 terms altogether. Okay. But since we're starting from p is equal to 0, then k cannot be 11, because 0 is also kind of a term on its own, or representing position. So we're going to say that k becomes 10. K will be 10, since we are starting the counting from 0. P0, P1, P2, P3, P4, which means the last number must be a P10, which will represent 11 terms. So that is 2.2. Question number 3, we've been given the general term of a quadratic pattern, Tn is equal to n squared plus Bn plus 9. Okay. And the first term of the first difference is a 7. Question, can we show that B is a 4? Can we show that P is a 4? So first term. This is the B. So 3a plus B must give us 7. What is our A? Our A is already 1 from the equation. So that's going to be 3 times 1 plus B7. Move the 3 that side. So it means it's 7 minus 3, which is a 4. Okay. Because remember, the general term is usually an squared plus bn plus c. Now the a is already represented by an imaginary one. I call it a ghost one. Okay, 3.2, can we determine the 60th term of this number pattern? Now, since you already know that b is a 4, then you can replace n with a, sorry, b with a 4. Then we're going to say that T60 is going to be 60 squared, where there is n. I'll replace the 16. Then that is 4 times 60, and then plus 9. Okay, so I punch that into my calculator, 60 squared plus 4 times 60 plus 9. It's a very big number. I'm getting 3849. 3849. or 9. Okay, then 3.3. 3.3, can you determine the general term of the sequence of the first differences of the quadratic number pattern? Can you write the answer in this sort of form? Okay. So, I don't know how one would do this, but we can start by, let's say, stating the original pattern. Okay. So if it was n squared plus 4n plus 9, so if n is a 1, that's going to be 1, which is 14. If n is a 2, that's 2 squared, which is a 4. 4 plus 8, 12, then that is a 21. And then if n is 3, that is 9 plus 12, 21, then that's a 30. I think that's enough. This and that, we say it's a 7. This and this is going to be a 9. Then this and that is a 2. Okay, so remember, the first difference will always represent an arithmetic. And you know that with an arithmetic, it's a n minus 1 into d. Our first term is 7 plus n minus 1. The common difference is a 2. Open that up. It's going to be 2n minus 2, which is going to be 2n plus 5. Okay, that's what I'm getting. They said it should be in the form of TP. It's 2n plus 5. But now, since we're talking about, does it make sense? It's, yes, TP must be a P, not N. So which means I'm going to change this to P. Then 3.4, okay. Which two consecutive terms in the quadratic have the first difference of 157? Which two have a difference of 157? So from the equation that I got of the TP is equal to 5P, is it plus 2? No, 2P plus 5. So it's 2P plus 5. Where there is TP, I'm going to replace with the 157 and then solve for P. So 157 is equal to 2P plus 5. I move the 5 that side. It's going to give me 152 is equal to P. Divide both sides by 2. For half of 152, I'm getting 76. So between which two consecutive terms? So it's between T76 and between T77. That is how 3.4 is meant to be answered. Then question 4, sketched below is this graph. So this format, when the x is at the bottom, it's a hyperbola. We have symptoms of H intersect at 1 and 2. That's okay. They want us to get the values of P and Q. So P and Q represent the values of their asymptotes, or the equations are asymptotes. So what we can see is that P within the equation, since this is a plus 1, within the equation is going to be represented as a negative 1. And then the Q will never change, to always stay the same with the signs. Then they want us to get the coordinates of the x-intercept. Now, since we have this, when we try to replace that, it's going to be 1 over x minus 1 plus a 2. One thing we know about the x-intercept, the y must be 0. Okay, so we're going to replace h of x with 0. So that's 0 is equal to 1 over x minus 1 plus 2. Then we can shift the 2 to that side. We're going to have a negative 2 into, why are you saying into? Negative 2 is equal to let's say x minus 1. And then you can multiply both sides by x minus 1, multiply by x minus 1. Trying to eliminate the denominators there. Then when I open this, I'm going to have negative 2x. This and this is a plus 2. Must give me 1. When I move this to that side, it's going to be negative 2x is equal to negative 1. Since 1 minus 2 is negative 1, I divide both sides by negative 2. So my x is going to be a half. Okay, since they want coordinates, it's going to be a half and 0. So you can see that it is cutting the x-axis. Alternatively, what would be other? Somebody say that, you know, take chances and just say yes, no. Then 4.1.3, can you write the x coordinate of the x-intercept of g if g of x is h of x plus 3? Now this 3 simply means we are shifting the graph 3 units to the left. Okay, we're shifting it 3 units. That's going to be. So this is a half. Now we must shift it 3 units. Should be somewhere. So it's the same as someone saying a half minus 3. I don't know, I'm getting negative. So saying a half is 3. So it's shifting this graph 3 units. So remember, if there's a plus, then we're shifting it to the left. If there's a minus, we're shifting it to the right. It only works with the horizontal only. Then 4.1.4, they want the equation of the axis of symmetry of H, which means the new graph. Okay, that is y is equal to x plus t. Now, the equation of the axis is this, H. Can you determine the value t? Okay, so if this graph is being shifted 3 units to the left, which means even this has been shifted 3 units to the left, the 3 units will make this to be at around probably negative 2. Does it make sense? I'm talking about the asymptote, particular asymptote. So if it's at negative 2, which means the points of intersection here are going to be negative 2 and positive 2. And those are the points that we normally use when we're finding the equation of the asymptote, so the axis of symmetry. So we're going to see y is 2. Now x is negative 2 plus t. I'll move the negative to that side, so that 90 becomes a 4. Does it make sense? Wait. We want H, not G. That's what's going to be. We want the equation of H. H is our original. So this is for G, which is 1 and 2. Thank you for that. So we're going to replace 2 is equal to 1 plus t. Move 1 that side, so t becomes a H. H, 2 marks. Okay, 4.1.5, tell me the values of x for which negative 2 is less or equal to 1 over x minus 1. This was our original graph. I don't know, it's okay. We can determine the values. Let's just solve it. We'll take chances and look at graph alone. So negative 2 is equal to 1 over, we're saying x minus 1. So this is that 2. Okay, so which means that if -2 is less than 2, simply means 1 over x minus 1 is 2 is perfect. So remember, this is our original graph. I choose to solve it at problem. Just need the points where this graph is above the x-axis. Okay. From the original, we said this was a point of a half. So from a half to the negative, the graph is above. And then on this other side, after 1, the graph will always be above. So the representation therefore can be x must be less than a half, or x has to be greater. You can't put it as sign because the one is an asymptote. So that's all. We just needed to express this in form of the original graph. Okay, then that is question number 4 and 1.5. 4.2. 4.2. They're telling us the graphs of f. Okay, they gave us the equation and g in this format. So it's exponential, it's a parabola, as sketched below. E and H are the x-intercepts. C is the y-intercept of f and lies on the asymptote. Two graphs intersect at D, which is the turning point. Can we determine the coordinates of C? So it's a 1-mark question. Remember, for as long as the parabola is given in this format, this last term, which is the constant term, will always be the y-intercept. So it's going to be 0 and -5. If you can't remember that, you could just know that at C, x is 0. Okay, x is 0, then substitute x with 0. You're going to get your -5. So that's -5 and 0. All right, let me just write it properly and say that's a -5 for C. Then they want us to get the coordinates of D, which will be the turning point. So remember, with turning points, what we said, can start by finding the negative b over 2a. Okay, our b is -4, so it's going to be negative and -4 over 2 times 1. And then that's going to give us a 2, which means the x here is a 2. Then for us to get the y, we just need to substitute this 2 into the original. So that we have 2 squared minus 4 times 2 minus 5. I'm saying f of 2b. Okay, so this is a 4 minus 8, which is -4 minus 5, which is -9. That's what I end up with, -9. So coordinates of D is saying 2 and -9. And then they want us to get the values of A and Q. So for A and Q, we need 2 points. Okay. Since we have C, or the coordinates of C, and they told us that C is the intersection of the asymptote, which means our Q is going to be -5 from above. Then what I need to do is just replace that -5 into the original equation and say that question mark 4.2.3. Okay, 4.2 3. A was 3 to the x, not 2 to the x plus 2. 2 to the x plus q. Now we say the q is a 5, but negative. Okay, so that's gonna be a times 2 to the x, that is the minus 5. Then we need just one point, which point that we got as 2 and negative 9. I'm gonna use this, replace it, or substitute it into this equation and get our value here. Okay, so where there is y, I'm gonna put negative 9. And the g of x, h of x represents y. This is a times 2, our x is a 2, minus 5. And I need to move this 5 that side to the negative 9 plus 5 is equal to 4a. This is going to give me negative 4. Equal to 4a, which means our a is negative 1. So we have a as negative 1 and then q as negative 5. A is negative 1 and q is negative 5. So guys, that is 4.2.3. Then they want us to get the range of g. Now, when they talk of range, they are referring to the output values or the y values for which the graph of g is valid. Okay. So what I can see is that below the negative 5, this graph can continue and move downwards and move downwards. So I can just say that y should be less than negative 5. Okay. As long as y is an argument of numbers, or just y is less than negative 5 is just good enough. Then 4.2.5, can we determine the values of k for which f of x minus k will always be positive? Okay, f of x minus k will always be positive. Okay, so what this means is if we look at our graph, remember this is f. So we're saying f of x minus k must always be greater than 0. In other words, the graph must be above the x-axis. Okay. So what that means, we need to look at the turning point, the coordinate, which is a negative 9. So how many units must we move this graph to be above the x-axis? It has to be 9 units up. So in this case, we're just going to say that k must be less than negative 9. As long as that is true, then that graph will be above the x-axis. Okay, because now if we have this negative 9 and it's time for us to replace it, it will change to a positive. Okay, so guys, that is that with question number 4. Then question number 5, we still have functions, the graphs g of x. These are straight lines, and its inverse as shown in the diagram. Okay. Then they're telling us D and B are the x and the y intercepts of G respectively. C is the x-intercept of the inverse of G, and then the graphs will intercept at A. Then 5.1, they want us to get the coordinates of y at B, the y coordinate of B. The y coordinate of B. So we know that the graph that is passing through B is the original, which is G. So without even calculating, we know that this is the gradient, 6 is the y-intercept. Okay, that is a challenge. Replace x with a 0. So 2 times 0 plus 6, that must give you 6. So the y-coordinate will be a 6, or y is equal to 6. Then 5.2, 5.2. They asking us, I'll write it somewhere here, okay? They want us to get the equation of the inverse in the form of mx plus n, or m of x plus c, already. Okay, so remember our original is g of x, which I can write as y is equal to 2x plus 6. But we know that when we are writing the inverse of any function, it's all about switching the x and the y. So this is going to be x is equal to twice y plus 6. Then move the 6 that side. So 2y is going to be x minus 6. I'm losing people now. No? Okay. Let's do this. So it's going to be x minus 6 is equal to y. Then divide through by 2. So that's going to be a half of x minus 3 is equal to y. So that will be our inverse. All right, then 5.3. 5.3, can we get the coordinates of A? So A is a point of intersection, okay? And at the point where graphs are intersecting, the two graphs must be equal. In other words, the j of x should be equal to the inverse. So I'll get the equation of j of x, which we said it is 2x plus 6, and then I'll equate it to the inverse, which is a half of x minus 3. Then I'll have to transpose, move this a half this side. So I know that 2 minus a half, I'm going to get 1,5x, or 3 over 2x. So I'll say 1,5x. When I move the 3 that side, I'm going to end up with a negative 9. Divide both sides by 1,5. This cancels that. Okay, so 9 divided by 1,5, that's giving me a 6, but negative. Okay, we can see that it's already on the negative side. Then I need to replace this negative 6 into the equation of g, or its inverse. Okay, so that's going to be 2 times negative 6 plus a 6. This is also going to be negative 6. So it's a negative 6 and a negative 6. Okay, so that is a negative 6 and negative 6. Then 5.4, they want the length AB. Okay, so we have the coordinates here 0 and 6. And then this is negative 6 and negative 6. We can use our distance formula. Yeah, I think it will make sense. So I'll say 5.4. No space up there, no, just that. So I'll say AB is the square root. Remember, it's x minus x1, x1 minus x2 squared, and then y1 minus y2 squared. Okay, I'm looking at 0, 6, and then I'm looking at negative 6 and negative 6. So if I look at my x values, that's going to be 0 minus minus 6, which is going to give me 6 squared. When I look at 6 minus minus 6, that's going to give me 12 squared. Okay, so 144 plus 36, I'm getting square root of 180. Okay, root 180 is giving me 6 root 5. I would just rather leave it like that, 6 root 5. Okay, limits. Then 5.5, they want the area of A, B, C. Okay. A, B, and C. Let's see if I connect that. Okay. Do I need an angle of inclination? You see this is 6 root 5. Okay. What are the coordinates of C? Do I need that? Do I need that really? I'm just trying to look for a quicker possible way of doing this without wasting time. If I replace y with a 0, x is going to be 6. So this must be 6 and 0 also. Okay. So this is 6 root 2. Even this must be 6 root. Okay. And then I have my axis. In that case, I divide it. Means I need to get the midpoint. How many marks? 5 marks. I think it's worth. Is it worth it? Okay. It makes sense though. What are the coordinates of the, as I'm thinking, that's gonna be a bit long. Okay. What if I break this into 2? But then I'm gonna need the coordinates of D, whatever cost. I break this down. And then I call this my height. This can be my base, that will be my height. I'll do the same thing. I get this as my base, and then 6 is going to be my height. Okay, so which means the only thing I need to get will be the coordinates of D. Okay, so I'll say coordinates of D. Okay, this is 5.52. Yes. 5.5. Okay, the same coordinates of D. We know that the line that is passing through D is our original, 2x. Okay, 2x plus 6. Okay, we know that at the point D, y is 0. So 0 is 2x plus 6. I'll move the 2x that side, negative 2x is 6. Divide both sides by negative 2. So which means x is negative 3. Okay, so if the coordinates here are negative 3 and 0, then what is the total distance here? So I'm having 3 units to the origin, and then I'm having 6 units to the right. So 3 plus 6, that's going to be 9 units, okay? Then I'll say that DC is going to be 3 plus 6, which is 9 units. Now, for as long as the distances are horizontal or vertical, in parallel to the x-axis or y-axis, and just add the values. Then if that is true, then I'm going to get the area of ACD, okay? Area of ACD plus the area of B, call it CBD, something like that. So this is a half, it's just the same base, and then the same height with the perpendicular height. Okay, that makes 90 with the horizontal with the base, that is 6 units. Okay, and then plus a half times 9 times 6. That's the same thing. So that is 3 times 9 is 27. Plus 27, which is giving me 54 units squared. This, I think, would have been the easiest thing. Alternatively, what somebody would have done also was just to get the distance BC using the distance formula. So that would be 6 squared and 6 squared, which is square root of 7, 2, which is like a 6 root 2. But that would also require to get the coordinates here, which would be 3 and 3. When we use the midpoint format. And then if we get this distance as our height, okay, our height let's see, okay. So square root of 3 minus 6, which is like a 9 squared, plus 3 minus 6, which is also 9 squared. I'm getting 9 root 2 as my h. So that's 9 root 2. I'm saying my base is 6 root 2. And the area is a half times base times height. So my base is 6 root 2 times 9 root 2. 6 times 9, still getting the same thing as 54 units. So whichever way, you said get the distance BC, get the midpoint, get the distance A, can call this T, AT or AD, no, AM, no problem. And then just substitute into the equation. All right, so that is question number 5. Then question number 6, which is the finance. Okay. So question number 6, they're telling us that 12,000 was invested in a fund that paid interest at M% per annum compounded quarterly. After 24 months, the value of the investment was this much. How much was invested? All right, so this is compound interest. So I'm gonna say question number 6. So 6.1, we know that A is equal to P into 1 plus I, the exponent of n. Okay, 12,000 was invested. We're looking for the interest rate. The annum compounded quarter. Okay, so I know that my n is 24 months, which is like 2 years. Okay, our P is 12,000. Our A, the accumulated value, is 13,459. We need the I. Okay, so I'm gonna say 13,459 is equal to 12,000 into 1 plus, I'm gonna say I over 4. Okay, because we are compounding it quarterly. And then this is gonna be 4 times 2, which is gonna give me 8. So I'm gonna multiply this by 4 quarters so that I have 8 quarters in total. Then what I need to do, divide both sides by 12,000. Okay, over 12,000, over 12,000. 13,459 divided by 12,000. Very big number. Let me just keep it like that. 13,459 over 12,000 is equal to 1 plus I over 4, the exponent of 8. And then I'll find the 8th root. Okay, remember what we said. Press your shift as if you're looking for the cube root. Then move backwards and change that. So the answer I'm getting is 1,01, then a whole lot of 4s is equal to 1 plus I over 4. Then I can move this one to that side, which will be subtraction. Left with 0,01444 is equal to I over n. Multiply both sides by 4. Okay, so times 4, it's 4. I'm getting 0, 0. Is it something like that? This is 1, 2, 3, 4, 4. Because of it. 1, 2, 3, 4. Is it what pi? Then I can multiply this by 100 since I'm not for the percentage. So when I multiply that by 100, what do I get? I get, oh, it's not making sense. 31.4 something, which is not making sense. What did I do wrong? What did I do wrong? Sounds gonna see, but you need to change that. Question is done, that is multiply this thing again and see. Because we're saying 0.01 4 times 4. Yeah, it's this guys. I'm getting 0.05776 is equal to pi. Then I'll multiply both sides by 100. It's gonna give me 5.7 and that of 8%. All right, so then now 6.2. They're telling us that on the 31st of January 2022, this person deposited 1,000 to an account that paid interest fees. The annum compounded monthly. We continue depositing the 1,000 on the last day of every month. Okay, we'll make the last deposit on the 31st of December 2022. All right, will this person have sufficient funds in the account on the 1st January 2023 to buy a computer that costs this much? Justify your answer by means of appropriate calculations. So, since this person keeps depositing money on a monthly basis on regular intervals, that's going to be what we call an annuity. Okay. And one thing we know is that since it's more like an investment, then we're going to look at the future value. Okay. So one thing we need to get to understand from this question is that the 1,000 is going to represent our X. This is our I that is compounded monthly. And then between 31st January and 31st December, we need to know how many N's are there. That's like roughly 1 year. Okay, so we're going to use the future value formula and see. Okay, so this is 6.2. We said we have our X as 1,000, our N as 12, our I as 7.5, compounded monthly. What else do we need? F, future value. Okay, so future value formula is given as X, open bracket, 1 plus I to the exponent of N minus 1 over I. So that's 1,000, open brackets, 1 plus 7.5%. It's going to be 0.0. Is that true? Yes. And then I'm going to divide by 12. Okay, over 12 to the exponent of 12. So I do nothing about the 12 since it's already months. I'll divide this by the 0.075 over 12. Then I just need to punch this into the calculator once and for all. No need of breaking down things So 1 plus 0.075 over 12. The exponent of 12 minus 1. Okay, 0.075 over 12. So I'm getting 1, 2, 4, 2, 1, 2, 2. That's what I get. 1, 2, 4, 2, 1, 2, 2. Now this guy wants to buy a laptop or a computer of 13,000. Okay, will he have sufficient funds? The answer is a no. He won't have sufficient funds. Just that. To that conclusion is needed. Something is shorting. Remember, our target is 13,000. This guy is having 12,000 plus something. Okay, that is 6.2. Then 6.3. The question is telling us that Tabo plans to buy a car. Okay, a car that is costing 250,000. He will pay a deposit of 15% and take out a loan for the balance. And the interest on the loan is going to be 13% on compounded monthly. Calculate the value of the loan. So if he pays 15%, what percentage is left? So it's like 100 minus 15. So it means 85% of this cost is going to be the loan. They find 85% of 250,000. You can do that. 0.85 times 250,000. Getting 2,1 to 500. That's how much I'm getting. So alternatively, someone can get the 15% and then you subtract from the 250. It's also fine. Then 6.3.2, the first repayment will be made 6 months after the loan was granted. And the loan will be repaid over 6 years. Calculate the monthly installment. So they want the HC. Now, money can never be idle. In others cannot be just kept and expect to pay whatever was agreed on initially. Money grows every other time. So for the first 6 months, the 2,1 to 500 is going to grow. And then whatever it would have accumulated to after 6 months, that's what we're gonna use, okay, as our present value. Since this is a loan, remember loans fall under the present value. Investments and savings, future value. Okay, so we need to find out the value of the investment after 6 months. Okay, so we're saying not investment, guys, the loan amount just after 6 months. So saying A is equal to P into 1 plus I to the exponent of N. So it is 2,1 to 500, 1 plus, so it's gonna grow with the same rate. Say it's 15% compounded monthly. That's gonna be 0.13 over 12. We say for the first 6 months. So let's use 6 since it's already months. 2,1 to 500 into 1 A to the exponent of what? 6. Having 226, 692,04. Okay, 0.04. Does it make sense, guys? For us to use 6 months, because there's an allowance of the month. So we say the loan will be repaid over 6 years, made the first payment 6 months after. Sorry, guys, then that is meant to be 5, not a 6. As we always give you an allowance of a month. to sort your life. Okay, so when I fix my mistake, that's a 5. Then it's gonna be 2, 2, 4. Okay, and then 2, 6, 2, 5, 3. All right, then we can now use the present value, which is given as x into 1 minus 1 plus I to the exponent of negative n over I. Now, since we want x, I can make x the subject and multiply both sides by I. And then I divide both sides by what is on top. So 1 plus I to the negative. When I do my substitution, that's going to be 2, 2, 4, 2, 6, 2, 5, 4 times my interest rate, 0.13 over 12. We're dividing this by 1 minus 1 plus 0.13 over 12 to the exponent of how many months are we looking at? Now remember, they told us we need to use 6 years now. The loan will be repaid over 6 years. We know that in 6 years, 6 times 12, that's going to be 72 months. But we've already moved some 6 months. Actually, not 6, but 5. We moved 5 months. So which means we only left with 67 months. So negative 67. Then I'll punch this into the calculator. 24262.53. Multiplying it by 0.13 over 12. Open brackets. We have 1 minus 1 plus 0.13 over 12. Okay, but to the exponent of negative 67. Close my bracket. Then I'm having okay, so I'm getting 4,000. Is it 4,000 or 47? 47, 4.96. So 4,724.96. So this is what he has to be paying every month. All right, then question number 7 is calculus, differential calculus. So question 7.1 will always be first principles. We have x squared plus x. So one thing we know, if this is f of x, we need to also get f of x plus h, which means where there is x, it will be now x plus h squared, and then x plus h. Okay, then we just have to substitute and say the limit as h tends to 0 is saying f of x plus h minus f of x over h. Then the limit as h tends to 0, our f of x plus h, remember we said it's x plus h squared plus the x plus h. We are subtracting our f of x, which was x squared plus x. Okay, and then I'm dividing this by h. Then limit as h tends to 0, I'll open this up. That's gonna be x squared plus 2xh plus h squared plus my x plus my h minus my x squared minus my x over h. No, it's not my h, just x. All right, then we can cancel out what is common. Okay, we can see that this x squared and this x squared is out. This x and that x will go. Then I can see 2xh and h squared, and this h, I can factorize out h. Okay. That's going to be 2x plus h plus 1 over h. I can cancel that out. And I know that as the limit of h tends to 0. I replace that with a 0, which means my answer is just going to be 2x plus a 1. So guys, that's what needs to be done for you to get all the 5 marks. Then 7.2, they want the first derivative of this. So in this case, we can just use the rules. So 5 times 2 is going to be a 10. And then 5 minus 1 is a 4. Minus 3 times 4 is 12. And then 4 minus 1 is a 3. And then that's just going to be a plus 8. I'll leave it at that. So we don't waste time with that. Then 7.3, they are telling us that there's a tangent to this graph. Okay. The tangent to the graph has a minimum gradient at this point. And they're asking us for which values of x will G be concave upwards. Now, when you talk about concavity, the main focus must go to the second derivative. Whether it's concave up or concave down, doesn't matter. So second derivative, now since they're talking about concave up, then you can say it's greater than 0. Okay. And if it's concave down, then the second derivative must be less than 0. So what are we going to do? I need to first of all get my second derivative of this. So I'll say my first derivative is going to be 3ax squared plus this and that is going to give me 6x. That's going to give me just a b. Okay, this is a constant, so it falls out. Then my second derivative, 2 times 3, that is 6ax. Okay, then 1 and that is going to be 6. The b will fall out. Then we know that at the point of x being negative 1, this must be equal to 0, second derivative. So it's going to be 6a times the negative 1 plus 6 is equal to 0. Then I'll have negative 6a. I can move the 6 that side is negative 6, which means my a is what? My a is a 1. Now the question is asking us for which values of x will G be concave upwards. So if our a is 1, which means it's going to be 6 times 1, which is 6x plus 6, must be greater than 0. I can move this that side. 6x is greater than negative 6, which means x must be greater than negative 1. So that would be the solution for 7.3. Okay. X must be greater than negative 1. Question number 8. Question number 8. They're telling us the graph of y, which is the first derivative of mx squared plus nx plus k, is drawn below. The graph is passing through this. It's passing through R, and it's also passing through Q. Okay, they want us to determine the values of m, n, and k for 6 months. Now, guys, this is a parabola, okay, that we know. So with the parabola, remember we said we have 3 formats. We have the turning point format. We have the turning point whereby we look at x plus p squared plus a q. We have the intercept format, x minus x1, and then x minus x2, something like that. And then we have the general one, ax squared, bx, and the c. So in this case, we have points. We have our intercepts. We have this as an intercept. Then we also have that as an intercept. So I think we can use the intercept. And then use this coordinate or these coordinates to find whatever is missing. Okay, so what I'm going to do, since I'm looking at the intercept, y is equal to a, x minus x1, x minus x2. Okay, then I'll do the substitution. So my y is equal to a into, I'll maintain the x, and then I'll change this sign. Since it's a negative, now it's going to be a positive 1/3. Then I'll multiply that with this. Since it's a positive, then it's going to be a negative. Okay. Then for me to get my value of a, I can look at the point R. Okay, so at R, x is a 0, and then y is a 1. I'll replace y with a 1. That's a. If this is a 0, then that's 1/3. If that's a 0, then this is -1. Then it's going to be negative a third a is equal to 1. You play around with that, divide both sides by -1/3. So a becomes a -3. Remember, this is a frown. Okay, a is a -3. Now, having obtained a as -3, then I can replace it back there, and then I open up that. Okay, so that's -3 into x plus 1/3, and then x minus 1. So I'll start by opening the two brackets and leave the -3 out. So x and x is going to be x squared. X in that is -x. That's going to be a third x. I'm using the FOIL minus a third. And I simplify this. I'm going to have -3x squared. I know that -x, okay, plus 1/3 is going to give me minus 2/3. Okay, I'm saying this combination here is going to give me -2/3. But that -2/3, I'm multiplying it by 3 negative, which means I'm going to end up with a +2. Then a negative and a negative, I'm going to end up with a positive on this x here. So that is the general equation. Question is asking for m, n, and k. Okay, so just the way that it's arranged. So we know that our m is going to be -3. Our n is a 2, and then k is a 1, which is also the y-intercept. All right, so guys, that's how I would have gone about that. Of course, there are quite lots of other ways. Since you have 3 coordinates, someone might choose to solve this simultaneously, whereby you replace x at each point. So you can start with 0 and 1, replace x with a 0, you're going to get the k as a 1. Then you go to the other point, replace x as -3, and so on and so forth. Then you solve simultaneously, those points will come out automatically. Okay, 8.2. If it's further given that f of x, okay, which means the original graph is this, can we determine the coordinates of the turning points of f? Okay. There are 2 ways to this. Okay. Someone might want to find the first derivative and solve for x and substitute, and that's a lot of work for 3 months. What one would do is just understand that the roots of the parabola, or the roots of the first derivative, will represent the x coordinates of the turning points. Okay, so which means our first turning point can be at -3, and then the other turning point can be at 1. So all we need to do is simply replace this -1/3 and the 1 into this f of x for us to get the y coordinates. Okay. So this is 8.2.1. Okay, so we're gonna say f of -1/3. Okay, I'm using the original, so we said -1/3 cubed. Okay, and then we are adding the square of that, -1/3 squared, plus just the x, and then plus it. Okay, so what are we getting? Getting 1/3, that is 1/9 plus 1/3, and that's a negative. Okay, and then plus 2. I'm getting 47/20. 47/27. That is true. Let me just confirm this. So we said -1/3 cubed plus -1/3 squared plus -1/3 plus a 2. Okay. Plus 9 and plus that. Yeah, that's what I'm getting. I don't know, someone is refusing. Someone is saying something else. Okay, let me just punch that again. Calculator is having issues now. Oh, it's cubed. Okay. Plus 1/9. Okay. And then plus 1/3. Okay. And plus 2. I'm still getting 47/27. Okay, so that is just the first point, 47/27. So which means I have -1/3 and then 47/27. So that's the first turning point. Then I also need to look at -1, okay, because we say the other, sorry, it's a positive one, not negative. Okay. So we say +1, where x is a 1. Okay, so that's gonna be 1 cubed. Okay. Did I do something wrong? Guys, I'm gonna revisit that again. Okay, plus 1 squared plus 1, and then plus a 2. Okay, so this is gonna give me a 3. So that I have 1 and 3. If someone is saying with the first one, there's a mistake made. So it's -x cubed plus x squared plus x plus a 2. Okay, so there's a negative outside here. All right, so let's see if I put that negative of mine there. I'm getting 49/27. Thank you for insisting. Okay, so 49/27 is our solution there. Okay, so guys, this will be the points of, those will be the coordinates of the turning points. And then they want us to draw the graph F, the original. Indicate on your graph the coordinates of the turning points, the intercepts of the axes, and so on and so forth. Okay, so this is 8.2.2. Okay, just write it out. So one thing we need to know is that we just need to find the intercepts. Okay, so for y-intercept, we know that x will be 0, and this number here. So which means y is gonna be a 2. Then we also need to find our solutions. Okay, so which number can we substitute in here to give us a 0? We need to look for the roots. Let's see. If I use 0, it's not gonna work. If I use 1, 1 is not gonna give me anything. If I use 2, if I use 2, that's gonna be -8 plus 4 plus 2 plus 2, which is 0. Perfect. So it means x must be a 2. Do I need to use the synthetic method? Yeah, I can. Let's see if we're gonna get, because those are the key points. This is A, B, C, and D. I'll write my coefficients. Okay. Let's see what we have. So they told us that x is a 2. Shade that off. I have my -1. Then -1 and that's gonna be -2. This and that is -1. Gonna be -2. This is -1. That and that's -2. That's a 0. Multiplying and adding. So which means my result on quadratic is going to be -x² minus x minus 1. If I take out the negatives, it's going to be x² plus x plus 1. Is there a scenario like where I can get something like that? Are there any roots to this kind of expression? No roots. So which means I'm just going to have x as a 2. So I'm saying no roots here. Since I cannot factorize, I can't even use a quadratic formula, I'm going to get errors. So which means the only x-intercept is the 2. So what I need to know is also the shape of my graph. Do that. Yeah, the shape of my graph. Now, since the A was a negative, which means I'm going to start with a smile and then a frown. As long as the A is less than 1. Why am I saying less than 1? It's less than 0. So a smile, then a frown. If the A was positive, then you start with a frown and then a smile. Okay, so we said x-intercept is going to be a 2. I can put a 2 there. My turning points, we said 1 and 3. Okay, so 1 and somewhere 3, somewhere there. Okay, the turning points, it's a smile. Okay, then the other turning point we said was -1/3, somewhere there. And then we got a 49/27. That's around about 1,8. So it means it should be slightly below, because this is a 3. So slightly below there. Okay, so that's what all we have. No? Y-intercept, we said is what? What's the y-intercept? We said it's a 2. Stretching. Let me put my 2. And then my 1 is going to be down there. Okay, so looking at this shape, we can just sketch something like that. Amen. Pastor, what's wrong with you? Guys, that would be the f of our graph. That's what one would have done. Okay, so we just look at these points, said it's 1 and 3. 1 and 3, this was negative a third and all of that. The intercept is a 2, and yeah, we only mark the intercepts and the shape, and yeah. Okay, move on. 8.3. Points E and W are two variable points on the inverse of f. I'm still talking the same thing. Oh, okay. And are on the same horizontal line. Okay. H is a tangent to the parabola at P. G is a tangent to the parabola at W. H and G intersect at the coordinates A and B. Now they want us to write down the value of A. Okay, if I can understand this question, points E and W are two variable points on this parabola. And then they're just on the same horizontal line. Okay, so if we have P there, they say E and W. Okay, so let me just assume I have this as my E. And then the same horizontal pattern, I have my W. Say they are tangents. So these are lines that are going to just meet the graph at one point. Then these two are meeting up. Okay, they intersect at D, which is A and B. Okay, and if that is true, they want us to write down the value of A. Wow. Okay, so what I'm saying is that if this line was just meant to continue, and so on, I can look at this one and then the negative 1/3. But since these two are meeting, then this has to be half of this. So negative 1/3 plus 1, and then I can divide by 2 since it's horizontal. So let's see if that's going to make sense since A is representing the exponent. Okay, so negative 1/3 plus 1, they will say divided by 2. I punch that into my calculator, and then I divide by 2. I'm having 1/3 as my answer for A. Okay, that is one approach. The other approach that I see in this case, since it's 1/3, if you look at this turning point and this turning point, they are more like they're indirectly asking for the point of inflection. Okay, that would be the A, the value of A, point of inflection. And we said with the point of inflection, you must get a second derivative. So if our original was negative x cubed plus x squared, was it like that? Plus x plus 2. Yes. So your first derivative would be a negative 3x squared plus 2x plus a 1. Then that would be a negative 6x plus a 2. Equate that to 0, move the 2 that side. And then x is at that. Yeah, makes sense. All right, then 8.2.3. They want us to get the coordinates or the values of B for which H and G will no longer be tangents. Okay, so we need to find how the value of B for which they will no longer be tangents. What does that even mean? what would that mean? Let's see. If I use 1/3 somewhere, there is something else. And I give me something else, which is k plus 1 over not going to make sense. Okay, so what I can see from here, since this was 1/3 as our point of reflection, they are asking us for which values of B is this graph or the graphs no longer going to be tangents, for which H and G will no longer be tangents. What we do. Okay, let's see. So if I get my 1, okay, am I getting the 1 from just this point here? And then I subtract my 1/3. Okay, 1 minus 1/3. That's going to give me 2/3. Is that going to make sense? Something. 5/3 minus 1/3. Okay, that's going to give me 4/3, which means my B must be complete dominant, so it should be less than 4/3. Okay, so that is 8.2, 8.3.2. Then question number 9 for 8 marks. They are telling us that f of x is x squared. Okay? They want us to get the minimum distance between the point 10 and 2 and the point on F. The minimum distance between the point 10 and this, and then a point on F. So one thing we need to know is that x squared is just a parabola, a normal parabola that is passing through the origin. Okay. That is x and this is y. That is our f. Now, when we talk of any point, it could be anywhere, which means if the x or if the x coordinate is x, which means the y coordinate is going to be x squared. But then they're telling us there's a point that is 10 and 2 somewhere on the graph, and put it there. Probably 10 and 2. Or it can even be below, doesn't matter. They want us to get the minimum distance between these two. So what I'm going to do, this is question number 9. So we're saying for point x and x squared, then we also have 10 and what? 10 and 2. So the distance between the two, you can use the distance formula, which is going to be the square root of x minus x1 squared plus y minus y1 squared. So to the substitution, that's going to be 10 minus x squared plus, that's going to be 2 minus x squared. When I open this up, still square root. Okay, this is going to be 10, 100 minus 20x plus x squared. Open that up. I'm gonna have a 4. That's gonna be minus 4x squared plus x squared. I can group everything and collect the like terms. Why am I having x squared 3? This is x to the 4. X squared. Okay. So which means it's gonna be x to the 4. This and that, I'm getting negative 3x squared. Okay. Then I'm having a negative 20x. Then I have 104. 104. That is my distance. Okay, then we know that for minimum distance, we need to find the derivative of what we have inside there. So I'm gonna get the ddx, okay, which is gonna be 4. I'm deriving what is the 4x cubed minus 6x minus 20. And then I can equate this to 0. Okay. Is there a number that I can divide, or I can just substitute to give me 0? If I try 1, not gonna make sense. What about 2? So 2 times 8 minus 12 minus 20 is a 0. So x is 2, gives me something. Then I can use 1, 2, 3, 4. I use my synthetic method. This is A, B, C, and D. This is 4, there's no squared here. This is a negative 6, and then there's a negative 20. Okay, so I'm gonna shade this off. My x is a 2. Then the 4 can be carried down. 4 times 2 is 8. This and that, I'm gonna get an 8. And then 2 times 8 is 16. This and that, and I add, I'm getting a 10. And 10 times 2 is a 20. When I add, I get a 0. So which means my resultant quadratic is gonna be 4x squared plus 8x plus 10 is equal to 0. Okay, so I have my first root as this. Let me see if I substitute here and I try to get the quadratic formula. Let me first divide by 2. 2x squared plus 4x plus 5 is equal to 0. So negative b plus minus, say b squared minus 4ac over 2a. Okay, if I try negative 4 plus minus, that's going to be 4 squared. I'm subtracting 4 times 2 times 5 over 2 times 2. So I'm already seeing that 4 squared is a 16. 4 times 2 times that, that's already a 40. So I'm going to have a negative under the root sign. So I'm not going to have any roots there. So which means we can only have a minimum when x is a 2. Okay? Then I'm gonna substitute this x2 back there. So which means my minimum distance is going to be 2 to the 4 minus 3 with a 2 squared minus 20 times 2 plus 104 under the square root. Okay, so that is 2 to the 4 minus, okay, minus, and then that I'm getting 2 root 17 as my answer. Units. The question wanted the minimum distance, and then that's what we get. All right. Then question number 10. They're telling us A, B, and C are 3 events. Okay. The probabilities of these events, or any combination of them occurring, is given in the Venn diagram. Okay, so we're seeing X here, we're seeing the whole of Y that side. And now they're telling us that if it's given that the probability that at least one of the events will occur is 0.893. When we talk of at least one event, they're telling us minimum is 1, maximum everything happening. Okay, which means if we combine everything here inside, the probability is 0.893. They want us to get the value of Y, where none of the events will happen. So if the probability that events will happen is 0.893, then for events not to occur, it will be 1 minus 0.893. Why am I saying that? Because the maximum probability under decimals of fractions must be a 1. So 1 minus 0.893, I'm getting 0.107. 0.107. That is what I'm getting. 0.107. Okay, then part B, they want us to get X, probability that all the 3 events will take place. Now, since we have this 0.893 to be equivalent to everything that is inside there, I need to add up all these values and subtract them from 0.893. Okay, we have 0.05 plus 0.15 plus 0.1 plus 0.05 plus 0.2 plus 0.183. So everything under it. So 0.05, I have 2 of them. So that. Okay, 0.893. I'm getting 0.16. 0.16 as my answer. Then 10.1.2, determine the probability that at least 2 events will take place. Now, when they talk of at least 2, which means minimum should be 2 events, but maximum, we can have 3. So we're gonna look at this, gonna look at that, gonna look at that, and then our X. Because this is for 2, for 2, for 2, but then we can also have 3. So minimum 2, maximum 3. So I'm gonna have 0.1 plus 0.2 plus 0.15 plus my 0.16. Okay. 0.16, I'm getting 0.61. That's my final answer. And then 10.1.3 are the events B and C independent. Justify your answer. Okay. Events B and C independent. This is 10.1.3. Events, we say that B and C. So from our addition rule, we know that this will be probability of B plus probability of C minus the probability of B and C. Okay. Then we also know that for independent events, the probability of, let's say, B and C can be obtained by getting the probability of B times the probability of C. This is the addition, and then this is just the product. So I don't see where I can use this because I don't have probability of B or C. So which means I can use this. I know that the probability of B and C, probability of B and C is going to be 0.2 and then the 0.16. Okay, I think I should just highlight that first. B and C is 0.2 plus 0.16, which gives me 0.36. Now, can I find this probability of B times the probability of C? Okay, so our B, when we look at B, B is going to be everything, which means it's going to be 0.183 plus 0.2 plus the 0.16 for X plus the 0.1. I'm getting 0.643. Okay. Let me first write it here, 0.643. And then probability of C is everything up there. So 0.05 plus 0.15, 0.16 plus 0.2. That is 0.56. And then I need to multiply those two and see. So that's going to be 0.643 times 0.56. 643 times 0.56. I'm getting 0.36. Because we are 0, 0, 8, and so on. Okay. So now we're seeing that the product of this is the same as what we already have in the middle. So since the two, so we shall say since probability of A and C is equal to the probability of B times the probability of C, therefore B and C independent. B and C will be independent. All right, so that is question number 10.1. 10.2, they're telling us that a 4-digit code is required to open a combination lock. And the code must be even numbered and may not contain digits 0 and 1. Digits may not be repeated. How many possible 4-digit combinations are there to open the lock? Okay. So what we need to first of all know, how many digits do we have altogether? Let me just have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Then from this 9, they told us we don't need a 0, we don't need a 1. Okay. So no zeros and no ones. Out, this is also out. Then they went on to say that the code must be even numbered. So we look for even numbers. So what are the even numbers? So we're looking at this, looking at this, looking at that. Are those even numbers? Yes. All right. The 4-digit code is required open. The code must be even numbered. What does that mean? Okay, and may not contain digits 0 and 1. But then they're telling us digits may not be repeated. Can somebody help us? What does the term even numbered mean? Does that mean no? No, something's off. If it's even numbered, you have to understand this English. The code must be even numbers. So it must be made up of even numbers. Yeah. We say the even numbers we have are 2, 4, 6, and so on. But it's possible for us to start with a 3, end with a 2, which will still be an even number. It's possible for us to start with a 5 and end with an even number. So it will still be even numbered. So which means, what if we start with a 6 and end with a 9? That won't be an even number. So it means 9 is out. So it means I'm looking at 2, 3. Okay, so how many is 1, 2, 3, 4, 5, 6, 7? So I'm looking at 7 digits. Now, since we have 4 that we must choose from, the first option will have 7 numbers to choose from. And then the second option will have 6 numbers to choose from, then 5 numbers to choose from, and then 4 numbers to choose from. Okay, when I multiply that, 7 times 6 times 5 times 4 is giving me 840 ways or combinations that we can get. All right, then 10.2.2, they're telling us that we need to calculate the probability. We need to calculate the probability that you'll open the lock at the first attempt if it's given that the code is greater than 5,000 and the third digit is a 2. So now we have conditions here. Okay. What can we do? So if a code is greater than 5,000, which means we have 3 possible options. Okay. We're gonna have codes that start with 5, the codes that start with 6, with 6, with 7. The codes that start with 9. But it can also be 6 and 8, no problem. There's 5, 6, 7, 8, and 9. All of them, it's fine, not need to. Then if that is true, how many digits am I gonna have? Remember, We said we're starting with 5. Okay, so this out. So we said we can start with 5, 6, 7, 8, and even 9 can be